this video, we're going to take a look at developing our understanding relating to inequalities. So the first question here says to complete the inequality in n below so that it has the solution set between 2 and 4. Now in this case it is saying that n is greater than or equal to this number, which is the lowest it's going to be, but it is less than or equal to this number, which is the highest that it's going to be. And it's a natural number. We could have told that from the dots. So the lowest it can be is 2. There is a dot on 2, which means it can be 2. The same with 4, it can be 4. So it's between 2 and 4. It says complete the inequality below to show in x below so that there is only one possible value for x. So thinking about this one, what does that mean? There's only one possible value for x, and it's an element of a real number. Well, in that case, we would be thinking that x must be greater than or equal to some number and less than or equal to another number. It can be any number that you want because it can be equal to any value, but you could just put the same value in there. And the reason why I'd put the same value in is because it's an element of r, and even if I strayed off it by 0.1 or 0.01, I'd have a problem where there'd be lots of possible answers between 5 and say 5.1. There's lots of possible answers between that. So I'd simply put in the same number. It doesn't matter what the number is, but I'd put the same number in each time. For the next one then, this is actually a mock question. It's from Examcraft and it's from 2021. And they asked this question where it says, indicate in the table below which statements are always true, sometimes true, or never true if a is a number greater than 1 and it's a natural number. So if a is always a natural number, will it always be true that 2 plus a is greater than 6? Well, I can definitely think of scenarios where it is greater than 6. For example, if a was equal to 5, 2 plus 5 is greater than 6. But I can also think of scenarios where it won't be greater than 6. For example, 2 plus 3, that's not greater than 6. So I'm going to put a tick in always or sometimes true, because it can't always be true. The next one, will 5 take away a always be less than 5? And the answer to that is yes. If you think about it, if you start at 5 and you subtract any natural number, that means that this side will always work out to be some number that's less than 5. Because it's going to start at 5, take away any positive whole number. So that's always true. 5 divided by 1 all over a, is that ever greater than or equal to 5? So divided by a fraction actually is the same thing as saying multiply by a. So 5 divided by 1 over a is actually simply the same thing as saying 5 multiplied by a. In that case, that will actually always be greater than or equal to 5, because if a is a number greater than 1, so it could be 2, 3, 4, 5, 6, 7, any natural number, then that means it will always work out to be bigger than 5. So I'm going to put a tick in always there. Is minus 7 plus a always greater than 7? No, it won't always be true anyway, because if I add 2 to that, minus 7 plus 2, that's not greater than 7. So it's definitely not always true. What about minus 7 plus 8? Well, that's still not going to work out, still going to be less than 7. But if I push it out, let me push it out to 15, minus 7 plus 15. Well, then it is going to be greater than 7, because minus 7 plus 15 will give me 8. So it can sometimes be true. And the next one then, is this true? Is 8 divided by a greater than 4? Is it sometimes true, never true, or always true? Well, in this case, we're going to have that a is greater than 1. And it's a natural number, which means the first value for a is 2. So 8 over 2, is that greater than 4? It's equal to 4, but it's not greater than 4. So that means that this is going to never be true for a values that are natural numbers. So all you had to do there was kind of think through what the different scenarios are if a has to meet this condition, and just think about swapping in different values for it to find out what a could be. The last one then, I'm going to put a little bit of an asterisk on this question because we don't actually know for sure that this is still examinable. Technically, the skills that you use for it, you will have to have, right? We just don't know if you'll have to do what we called a compound inequality, where there's 2 parts to it. But you know what? It's going to be the same as if it was just 1. So I'm going to show you what you do. You're going to take this part and write it out as one inequality. So minus 7, 8 is less than 8 minus 3g. And I'm going to take from this part down to here. So you split it just after the inequality up to the end, or at the very start up to just before the start of the other one. So you're setting up 2 inequalities. So we'll have 8 minus 3g is less than or equal to 11. So now we're going to solve this. So what I'm going to do is I'm going to take away 8 from both sides. So I get minus 15 is less than minus 3g. If I want to get g on its own, I need to divide both sides by minus 3. Now, whenever you divide by a minus, alarm bells need to go off in your head, because there is a rule when it comes to inequalities where if you divide by a minus, you have to change the direction of the inequality. So we will get plus 5 on this side, we will get plus or positive g on this side, and I had to change the direction of this inequality because I divided by a negative number. That's one way in which it differs from equations. Do the same sort of thing on the other side. So I'm just going to solve this. So I'm going to take away 8 from both sides, and I get minus 3g is less than or equal to 3. Again, to get g on its own, I need to divide both by minus 3. And then what I'm going to get from here then, if I've divided both sides by minus 3, I'm going to get 1g, or just g. I have to change the direction of the inequality. Why? Because I've divided by a negative. Really important that we watch out for that. And then we have that it's greater than or equal to then, because I changed this direction, it's greater than or equal to 1. Now I simply have to put my inequality together, and I'm going to write it with my smallest term on the left. So I'm going to say 1 is the smallest that it can be, and g will be greater than or equal to that, but it will be less than 5. So the biggest it will be is 5. So it's between 1 and 5. Again, we don't actually know for sure if this is examinable. You have to be able to do inequalities. You have to be able to read inequalities where you're given an interval. Do we have to solve compound inequalities? Unclear as of yet. Until we get a few more exam papers, we won't know for sure, but it's good practice, because if you can solve this, then you can solve any inequality.